Today's video, we're going to build a game with Flutter using Flutter 3 and the new Casual Game Toolkit. So let me give you a quick demo of the game that we're going to build in this video, and it's actually just going to be a Connect 4 game. If we go ahead and click play here, you'll see we have a Connect 4 board, and I can just go ahead and drop a tile in and probably drop 4 in a row and win just like that. So really the purpose of this video is to show you how to build some game logic and actually how to use this template. So you might notice already that this game isn't really finished and there's kind of a lot of things missing. However, the concepts that I'm going to show you in this game are really just how to use this template. I do want to make a quick shout out to Philip here, who actually built this game template and also built the tic-tac-toe example, which this example is based off of. Both of those you can check out. I'll link them below, and I'll also link to his YouTube channel and GitHub, which you should also definitely go check out. If you're ready to build your first game, then this video is for you. Grab a cup of coffee and let's get started. All right, so we're going to begin by going to the Flutter samples and then getting the game template sample. And we're going to go ahead and clone this. You are going to actually have to end up cloning the entire samples project. All right, so within my code directory, I have the samples, and then if you look at the samples, it's basically just exactly the same as what is on GitHub. So we have that game template here. So I'm going to go back out to my code directory, and now I'm going to make a copy of this game template, but rename it to Connect 4. So you can do that with a cp-r, and then you're going to give it the directory that you want to copy, which is going to be that game template. And then you're going to give it the directory you want to copy it to, which I'll call Connect 4. We should now have a Connect 4 directory, so we could go to that. And from here, we can actually just open this in Android Studio. All right, so we're here in Android Studio, and there's really just one thing we need to do, and that is to update this analysis options. You'll notice there's kind of a red underline here. This is all caused because in the actual GitHub samples directory, there is a analysis options at the highest level here. So all this file is doing is actually defining a few rules that this whole entire Flutter samples code base will follow. But since we copied the game template by itself, we don't actually have this file, although we do have a file within the game templates directory, which is its own analysis options. It's just not going to inherit analysis options, so you can just remove that line. But we can also take the analysis options that are in that highest level and just copy that over and paste that into our game template file. So then the only thing we would do is just take these two rules that were included with the template, and we will keep them. So we'll copy those and just put those down in here. And then the rest of the defaults we'll leave as well. Then you can just delete everything that used to be there. And now this should be set. The next thing we need to do is open up this terminal and actually run flutter pub get. This will just install all the dependencies that the game template already has. And now at this point, we should be able to actually run the app. So go ahead and try and run the app on a simulator device. All right, so now the game is running. You can see you can click play. And this is just the basic template game with absolutely no modifications. So we're going to start making some modifications to this game template. The first thing we're going to do is update this main page here. And there's not a ton we're going to do here. Mainly, we're just going to change the name. If we go into the lib src and then find the main menu, we can find the main menu screen. And that is the screen that we're looking at right here. Find where it says Flutter game template, and we're just going to change that to Connect 4. And that looks good. If we increase the font size a little bit, it'll go to 2 lines for the iPhone. The next thing we're going to do is remove that debug banner, which actually is going to happen in the main.dart. And this is, I believe, the only change we're going to make to main.dart. You're going to want to find the build method here. And after the multi-provider, you should find the material app. So very much towards the bottom. And we're just going to set the debug show checked banner to false. I don't really like having it up there, so I always kind of remove that. We can also change the title here to Connect 4. That is it for main.dart. Now back in the main menu screen, when you click the play button now, it brings you to the level selection. However, in this game, we're not going to have any levels. We're just going to have the one board of the Connect 4 board, and then let the user play the game and replay the game. and keep replaying the game, but not actually implement any levels. So for right now, we're going to actually make this button go directly to what would be level 1. So back in the main menu screen, we want this play button to go to level 1. If you go to the level selection screen here, you'll be able to see what the actual Go router is for that. And right here on line 52, the router is actually just going to go to the play session of the level. So we can actually copy this line right here, and then back in the main menu screen, find the play button. Here it is right here. And instead of routing to the actual play route, we're going to route it instead to that level, but we're going to just hard code a 1 for now. This is all basically temporary. It'll make kind of testing this quicker because we won't have to go to that level page. But now when we click play, we're going to be just on that level 1 screen. You'll notice if you go back here, it is going to actually bring us back to the level select. However, we really want that to go back to the home screen, so we can go ahead and update that button as well, which is going to live in the play session and then the play session screen. And if you scroll down to the bottom here, you'll find the back button. And right now it's just doing a Go router of context pop. We can just change that to go to the root path, which is the home page. Now the back button will bring us back here. The play button will bring us to the actual game board. Now we can go ahead and update this page, which is our actual game screen. So the very first thing you might notice is the settings icon and also the button are kind of spilling off of the screen. And we could quickly fix this by adding a safe area around the stack here. So you're going to want to find the scaffold and then basically make the first widget within the scaffold a safe area. That will kind of clean that up better. The next thing is we're actually going to remove this back button from being down here and just place it up here, kind of opposite the settings button. Find this column here, and this is really going to contain everything that's on this page. Really the first thing within its children is that settings. We can remove this align and then go ahead and wrap this ink response in a row. And now this row can have 2 buttons, which are just ink response. And the one is going to be the settings. The other one is going to be the back. The back we're going to want on the left side, so we'll go ahead and change this route to the back route. And if we go down here, we can see what our back button looked like. And the text just says back. While we're down here, we can also just go ahead and remove this back button. Then we just need to change this to be back. And then for the settings, there is already an image within this template that is a back.png. So if you save that, you'll see we now have the 2 icons and they're not spaced the way we want them to. So just within this row, we can add the main axis alignment and then set that main axis alignment to space between. So that looks good. Now we can go back and we can hit play. Settings will still work. We're not really going to touch any of this, but this looks good now. We'll leave the spacer here, and then we can delete everything else until the last spacer. So we'll have the spacer, and then we're going to create a new widget here for the game board. But if we save this, everything looks pretty good. You might want to add just a slight bit of padding around the buttons as well up here to move them in a little bit. But other than that, we now kind of have a clean state here, and we can go ahead and create that game board. There is logic obviously in here for the game level, and I'm just going to leave all of that for now. If you're actually following along and building a game, you will want to add levels down the line. If that's a video you want to see, comment below and potentially I can make that as an add-on to this video. So now at this point, we can actually go ahead and add that game board as a new widget. So we're going to create a new file, and this is going to be in the play session. So that's the same directory that this current file we're working in is in. And this will just be a new Dart file. We're going to call this the game board. And the game board is going to be a stateful widget. And we will need to import material. Now this game board, you can see this final version here is just a grid view of essentially tappable buttons. So this game board is just going to generate this grid view here. Because of the way we're adding these into this column, we are going to need to set the size of this. So we can begin with a sized box here, and we're going to set the height to be 400. And the child here is going to be an expanded widget, which is going to contain that grid view. So we can call gridView.count on this. And this is going to take two parameters. One is the cross-axis count, and the other is going to be the children. So the cross-axis count is going to be the number of columns. So we're going to have 7 columns in this. And then the children are going to be what fills up this grid view. So I believe this is going to be 0, 0, and then it'll fill up and kind of just go in and fill in this column. So we want to make sure we have the right amount of children. We're going to quickly define the rows and columns up here as integers. And we want to have 5 rows, and then we want to have 7 columns. So we can just replace this with calls there. For the children of this grid view, we're going to use a for loop to generate enough elements to fill up the whole board. So we can create a for loop here starting at 0, and then we're going to go until we hit the total number of tiles. So we could do the calculation for the number of total tiles right here, but to keep our code a little bit cleaner, we're going to actually move that logic over into another file and then call it from here. So we'll put all of this on pause right now, and we're going to create a new file. We'll put this file in the game internals, and we're going to call it the board setting. So this is just going to be a simple class, and it will have an initializer. So we're going to actually create this. What this is going to allow us to do later is if you do want to have levels, and say for instance you want the board size to change depending on the level, this is going to allow you to easily change the board size without having to go into the code and change anything. All you have to do is change the board settings and then pass those settings in to the rest of the app. So we need the rows and the columns, and these are both going to be integers. And then we can initialize this and require both of those. I'll actually define calls first. So now we can create another function in here, which is going to return an integer, and this will be the total tiles. So this will tell us how many tiles we need to fill that grid view with. All we need to do is multiply the rows by the number of columns, and we will have the total number of items that we need in the grid view. So here we can just return the calls times the rows. And that looks good. All right, so now within here, we can actually just go ahead and remove these two defined integers, and we're going to require that a board setting is passed into our game board. And the reason for this is we want our board setting to be defined in our play session screen, because that's where, if we do go with levels, that's where the level will be known. The game board itself is going to require a board setting, and we can just call this the board setting, and we'll update its constructor here to require that board setting. Now down here, when we set the cross-axis count, we no longer have that calls because we just deleted it, but we can use the board setting, which is now accessible through widget.board settings, and then call calls on that. So whatever the instance of this board setting calls is what will be used here. And then for the children here, we can now use the board settings total tiles and basically loop through that amount of times and then create a tile for each one of those. For right now, we'll just return a text widget with the index. And we actually do not need these brackets. And this should be a comma. And we also need to throw a var before there. Forgot a comma there as well. But now this looks good. All we need to do is probably just wrap this also just in a string. Now we can call this game board from our play session screen, which we put a comment before about. And this is going to require that board setting. So up in the beginning here, we can just go ahead and define the board setting, and we'll also call this board setting here, and it's just going to be an instance of board setting, and this is where we can define the columns and the rows. So we're going to have, again, 7 columns and 5 rows. But now you can see if you were going to change this based on the level or really based on anything you want, all you would have to do is actually just change the instance here and it will change the shape of your board. But we have to finish calling this, so we'll take the board setting here and set that within our game board there. We need to import the game board, and if you save this, you'll see we're getting 0 through 4 printed out, but this isn't exactly what we expect. So we must have a typo. And if you go to the board setting, you can see that this should be a multiplication, not an and sign. And if you do that, you'll now get all of the tiles printed out. And that is looking good. So we now have our grid starting to take shape, and we are building this in a way that we can change the board as we like. So now let's make these tiles actually look like the tiles we want in our game. In our play session directory here, we're going to create a new Dart file, and we'll call this the board tile. This will be a stateful widget, and we'll have to import material. And this is going to require two things in its constructor. One of those is going to be that board index, which you can see is actually being displayed right now. And the other will be those board settings. So we can include both of those, and we will need to import the board settings. Then we can require that both of those are passed in our constructor here, which we will update like that. We're going to want this to be clickable. So instead of returning a container here, we can go ahead and return that inc response. This just allows us to have an on tapped, which currently we're going to just leave blank, or actually we could print out tapped and then give it the index. But the main thing here is we want to build out the container that actually has a background and a circle. So blue background and a circle. You can think of these as all being individual squares. To do this, we're simply going to have a child here, and this is going to have a container. And we can set the color of this container to be that blue color, which is going to be that background color. The child here is going to be another container, and this is where we're going to build out that circle. To build the circle, we can have a decoration, which we're going to use a box decoration for. And then we can set the color of this circle. To set the color the same as this background color, which is going to be the default, we can use the palette. And this is something that comes with the template. If you go into the styles and then the palette, you can see what these colors are that are kind of default set already. And we have a background play session. So this is going to be the color that we're going to set. Obviously you can customize these colors how you like. And then further, that palette is actually set up through provider. So you can just access it through provider, and you can do that with a context.read. And then we would read the palette, and then you can call the color that you want, which is going to be the background play session. Next, we can do the shape. And since we want this to be a circle, we will do a box shape of circle. Then this container's child, we can simply put the text, which is just going to be the index right now. So we can just put the board index in there. So now back in our game board, we currently have the text just printing out for each of these. Instead, we're going to use our board tile. The index here is going to be I, and then the board settings is just the widget board settings. So if we save this, you'll see it looks better, but not quite what we want. So if we go back into the tile here, there's a few things we need to change. Firstly, we need to center these numbers into the middle of the containers here. That's simple. We can just wrap the text with a center. Next, we can add that little gap in between each of the blue lines. So to do that, we can just wrap this larger outer container in a little bit of padding. If you save that, you'll see they kind of shrink in. 8 is quite too big, so we'll go with 1. Now the circle is kind of spilling over the edge, so we can add a little bit of margin there. So in this interior container, we can add a margin of an edge insets for all of the sides and give it a 3.0. So that looks pretty good. We now kind of have our game board set up. And if you click on any of these, you'll see you get your tapped and the number. As you can see, we have our game board here, and we have all our tiles being displayed with their index, but the index isn't really as useful to us as it would be to have the actual coordinates. So you can imagine this like it is just a grid. And if we wanted this tile here and we click on it, we, instead of it saying 31, which the runner is saying that tap 31, we would rather know what the row and column is of this, or the X and the Y. So this would be at column 4 and this would be at row 1. So we're going to update these to actually display our coordinates. And in the process, we'll create a data model for each of the tiles data. and we're just going to go ahead and call that tile, which later we'll be able to use when we're trying to determine who won the game. In our game internals, we're going to create a new Dart file, and this one we'll just call the tile. This will also just be a class. Basically, all this will be is the modeled data of what a tile can have. So currently we've built what the view will look like, and now we can build what the actual tile object is and the data that it holds. So a tile is always going to have a row and a column, which you can think of them as an X and a Y if you prefer to look at it in that math sense. I prefer to name them row and column, but it's the same thing. Every time we create an instance of a tile, we are going to require that row and column. Next, we're going to create a way to actually generate a tile based off of just this index. So that is going to be another way of generating one of these. You could generate it with just the column and the row, or you can generate it with this factory, which is going to be from the board index, and it's going to require two parameters. One of those is going to be that board index, and the other one is going to be the board settings. We are going to need the board settings for this because we're going to need to know the shape of the board. If we know the index and we know how many total rows and columns there are, we will be able to do some math and figure out actually the coordinates of that tile. So that's what we're going to do here. So we want to figure out the column of that tile. So you can imagine if we were taking this one, for example, 31 was the index, and we have access to the width and height of this board. So this logic here is going to get us the column and the row given the index and then the board settings. If you walk through the math yourself with a few number examples, I think you'll see how it's working, but essentially what we're doing is we know where this is on the board. We're just figuring out its coordinates based on the board itself, and then we're going to return that tile from there. So back in our board tile, we can actually call, instead of the text with the widget, we can actually call a tile here, but we're going to define the tile up at the top here. This will be a final for the tile, and it's going to be a tile from the board index, and then we're going to give it that board index, and we also need to give it that board settings. And we will have to also import the tile. So now we can have this tile here, and we will have to wrap this in a string. And we're also going to call toString on this, because the tile is not actually a string. But we can call toString on it. This will actually need to be defined within our build. So we'll just move that down. This isn't going to quite work because we do need to override our toString on our tile class. So when you're in the tile class here, you can simply override what you want toString to do. And we want this to return a string. So when you call toString, we're going to just return a string that has the row and the column for the tile. We're actually going to do the column first because that relates to the X, and then we will do the row, which relates to the Y. We don't really need a space there. So that should work, and let's see. This should work as well. What are we missing? This actually does need to be still wrapped in that text widget, and since this is a string, we don't need all of that. So if you save that, you'll see the update here. So the coordinate choice here is one that I made that you might choose not to make. And mainly that's starting with 1, 1. You might want to start with 0, 0, and that's fine. So to explain this a little bit, you can see that this row right here all has 1 at the end because this is the first row, the second row, third row, fourth row, fifth row, and then very similarly, each column is also defined. So essentially now these all have a unique value that we can use, and we can store these values and essentially assign them to each player and then determine the win state based on that. So the way the game is going to work is the player will click a tile and that will place their tile, then the computer is going to play their move. So now what we're going to do is actually start to hold the state of the tile once it's clicked. So in our game internals, we're going to create another new class, and this will be a Dart file. And this one is going to be called the board state. The board state is going to hold the logic pretty much for the entire game. And the way it's going to work is it's going to be a change notifier. So what that means is we can actually make changes within this board state class, and then we can notify our listeners like the board or a scoring mechanism or anything really. If you haven't seen the change notifier concept before, it's a part of provider, and I will put links down below. So if you're not familiar with that, definitely go check out that before continuing on. But we'll create this class here, which will be the board state. And this is going to extend the change notifier. We're not going to need it directly yet, but we will eventually need the board settings, so we might as well make our constructor now require the board settings. We will need to import that as well. To hold the state of this board, we're going to simply create two different lists, and one list is going to be for the player. The player would be the actual person playing, and then one list is going to be for our computer, which we're going to call our AI. We can create these two lists, and they're both going to be empty to start, but they will be filled up with the tiles that get taken. So we are going to need to import the tiles. So these will be obviously the tiles that were taken as the gameplay happens. Now create a function which is going to not return anything, so it'll be a void function, and we're going to call this make move. So this will be what is called when someone actually clicks on a tile, and it is going to require that tile that they click on. And for right now, we're just going to add that tile to the list of player taken, just to demonstrate this. And then after that is done, we're going to notify the listeners. Let's go ahead and get this player taken list displayed here just so we can see what's going on. Back in our play session, if we find our multi-provider here, we do already have a change notifier provider for the level state, and we're going to add another one here. That one essentially isn't really used, but we're going to add another change notifier provider. And with the create, we will have access to the context. And then we want to add the board state here, which we will have to import, and that looks good. So all of the widgets below this will now have access to the information in our board state. To display that list, we can go down towards the bottom here, and after the game board, we can create a consumer now, and the consumer is going to be consuming the board state. And this is just basic provider features here. Now we have this builder, and within the builder, we're going to have access to three things. One is the context. The next is going to be actually the board state, so we'll call that board state. And the last one will be the child. Now from within here, we can return something, and we're going to just return a column. And then within the column, we're going to simply use that board state and access the player taken and the AI taken. We will need to rerun the app here, but what you're going to see is this error here, and the error is actually that we're trying to build this, but we don't have the right context here. So we need to actually wrap this whole thing in a builder. So we're going to look for this center here, which is basically everything. You can see everything that is in our game here, in our game stack. All this is the celebration, which happens when you win. So we're going to wrap this container in a builder, and the builder will have a context, and then that context can be used. That is one issue, but we also have another issue, and that is we need to actually return the provider here, and instead we just had it within this change notifier provider, but we actually need to return it. So if you save that now, you'll see we have the player and the AI here. I'm going to add one spacer below all of this just so it's a little bit easier to see. So when we click these buttons now, we actually want to make the call to this make move. So currently we define this, but we aren't calling this make move anywhere. So that is going to happen back in our board tile. Currently the on tapped is just printing out that it was tapped. And since our board tile is a child of our play session screen, we will have access to the board state via provider. And for this one, we want to set the listen to false, because this specifically is going to be calling a function within this provider's class. So when onTapped calls this provider's board state, we're going to be going into essentially the board state and calling this. So we don't need this to be listening for anything, because this is actually just kind of making the action. So now we can call the make move, and we do need to pass in that tile, which we already have defined up above. We can now click on one of these tiles, and you'll notice nothing is happening. We were expecting that this would get filled, but if we go back to the board state, you'll see that we aren't actually notifying the listeners. We have this commented out, so we're going to uncomment that. And if we save that immediately, that one that I clicked will be notified, and that will go there. So if we click again, we can click on any of these and they will continue to go into that player list right there. So this is a good start. you'll notice now we kind of get stuck at this point. If we want to clear this out, we can't. So now is a good time to create the reset button. All right, so the reset button is going to be in the play session screen. And we'll do this right above the player and AI lists that we're displaying there. So let's add another spacer here. And in between that, we're going to create a new button, which is just going to be an elevated button. But we are going to make this a button with an icon. So we can call elevated button.icon. And the on pressed here is going to be a call to that same provider, which is the board state provider. So we could call this just like we called provider here, where we call it and call a function, and that would work fine. And we would change the function, obviously. But another way that you can call this is just to use the context directly, and then you can read the context of the actual board state. And then from there, you can just call the function that you want. So we didn't create this function yet, but we're going to call it clear board. And now we need to create this function. So back in our board state, we can create a new function, which will be a void function as well. And all that we want to do here is reset the lists here. So we're just going to clear them. And then once we clear those, we're going to need to notify those listeners. And since we already have the listener set up down here, it should just notify that same listener with the update, which the update is just that these are now cleared. We just need to finish building out this button, which I will just paste in here. So we're going to have an icon and we're going to have text that is going to say reset. So if we save this, we now have this reset button. So if we add a couple things to this list and click reset, you'll see now it goes back to an empty list. When we play our game, when one of these is clicked, the tile actually turns a different color. Currently, when we're clicking these, nothing is actually happening on the board. So let's go ahead and set it up so that the tiles within this list are actually turning a different color. So firstly, we're going to define what colors we want to set. This we can do in the board state again, and we're going to just create a function that returns a color, and we'll call this the tile color, and this will take a parameter of a tile. So we can start this with actually doing a little bit of a refactor and just simply return the color that is being set here now, which is defined in the palette, and it's that background play session. We will need to import the palette here. We don't really have access to the provider, so we're going to have to create a new instance of this, which isn't a huge deal. Now we can update our tile. So if we go to our board tile, you can see here we're setting the color of this circle to be the palette background color play session. Now we're going to set this equal to the board state's tile color, which is this function right here. So this function is going to define that color. So we are going to need to wrap this container now in a consumer, because this is going to need to listen for updates. So similar to back in this play session, how we have this consumer for the board state, we are going to need to wrap this container here in a consumer. So a consumer is really just a type of a builder. So we can wrap this in a builder and rename this part to be the same as what is here, which is going to be this consumer with the builder that has those three elements. Now we have access to the board state here. And since this is a consumer, it will be listening when we call notify listeners. So we can call the board state now and then call tile color. And we'll pass in the tile, which we already have defined up here. It's best practice to have your consumers as close to the elements that need them. Our example is kind of simple because it's just a background color, but you can imagine if you had a larger widget and you only want to update, say, a notification icon number, you could just wrap that in the consumer and not have to rebuild the entire larger widget. But from here, if we save this, we should see actually that everything is still looking the same. And our color now is coming from our board state here. If we were to return a different color from here, it would actually change that on the board there. So that's good. That's a good refactor. But now we want to actually make these colors change based on if that tile is in one of these lists. So the way we're going to do this is actually determine who the tile owner is. We're going to create some functions that help us determine that. We could write all that logic right within the tile color here, but we are going to be using this in multiple places. So having a way to find that owner just by the tile itself is going to be a useful function to have set up. So first we'll create an enum, and it's just going to have the options of the tile owner. So we'll call this the tile owner. It's going to have 3 options. It could be blank, which means there's no owner. It could be the player, which would be the actual person playing, or it could be the AI. So now we need a way to set this for our tile, and we'll do that with another function. This will just be a function that returns a tile owner. We will call this get tile owner because it is just going to get us the tile owner. We're going to need to pass in a tile, and now we can start our logic here. So we want to check if the player taken list contains the tile, and if it does, then we're going to return that the tile owner is the player. Pretty simple. We're going to do the same thing, but instead we're going to say if the AI taken contains the tile, then we'll return that the tile owner is the AI. And then if neither of those are true, we'll just return that the tile owner is blank. This is good. Back up in the tile color here, we're going to kind of do a similar type of logic, and we're just going to be checking if the tile owner, so we can call get tile owner, that equals the tile owner of the player. Then we're going to return a color of amber. And this logic is pretty simple, so I'll just fill it out here. But basically, if the tile owner is the player, it'll be amber. If it's the AI, it will be red. And then if it's blank, it will just be the default color that we already have. So if we save this and rerun it, this is working. And when you click any of these, you can see they turn to the player's color. It's still expected that the AI is not going because we haven't set that up. This is a good time to commit, and then we will work on our game logic. With Connect 4, you obviously want these to fall to the bottom. So right now, if I'm clicking on any of these, they're just lighting up. But we want to change this so that if I click, for instance, any item in here, it's going to fall to the bottom and actually highlight this one. So we're going to need to write this logic so that any tile in this column here is going to actually build them up from the bottom. And further, we need to make sure that if I click this a second time, that it then goes and places it on top of this. So basically how you would expect the Connect 4 board to work. So for this, we're going to create a new function, and we're going to call this evaluate move, and it will return a tile. It's going to also take a tile. So we're going to pass the original tile into this. And what we're going to do is loop over the number of rows and find the lowest blank row for this column. So you can imagine if I click 4, 4 here, the lowest blank row is the first row. The column is always going to stay the same. So to do this, we can loop over all the rows. So we're going to use the variable bRow, which will stand for board row. We're going to start at 1. So we're going to be down at the bottom, and we're going to be checking if the first row is blank. And then we're going to keep going up until we get to the top of the board rows. So we're going to create a new tile that we're going to evaluate. And this tile is going to be within this column. So within our example here, the column, let me do a better example, which would be 5, 4, so the numbers are not the same. So within 5, 4, the column here is going to be the 5th column, and that's always going to stay the same, but the row is going to change. So the row is going to start at 1, so we're going to be checking this spot right here. And now we can check the owner of that tile. So we can get the tile owner and see if it's blank. If the tile owner is blank, then we're going to simply return this eval tile, because this tile, this eval tile, is the one that we want the actual game to highlight. This is really all we need, because even if the one that you click is the lowest one, it will just return that. So now we can call evaluate move within our make move. So right within here, we're going to create a new tile. We'll just call it new tile. And that will be the tile returned from evaluate move. We also need to make sure we return null at the end of this. And that's why this is a tile with a question mark, because it could be null. So if none of these are available, this would just be null. And that would be the case if you could imagine if you had this completely filled and you tried clicking one of these. We don't want to allow you to play that, so we will just return null. So we can actually now check if this new tile is equal to null. And if this is the case, then we want to alert the user that they can't actually make this move. But we'll come back and do that later. Right now, we're just going to take this new tile and use that for the players taken. But one thing we will do here is just return, because if this is null, we don't want to do any of the logic down below here. At this point, we know that this new tile is an actual new tile. We can reset this, but I don't believe it's going to work. So now we can rerun the app and we'll go ahead and test this again. So if we click on 5.4 now, you can see the board doesn't actually highlight anything, but the player is marked as 5.1, which is what we would expect. And if we go again, it will actually mark 5.1 again. So that's kind of an issue, and it has to do with our getTileOwner function here. And really it has more to do with using player taken.contains and checking a tile. So what's going on here is that we have a tile instance that has the coordinates of 5.1, and we're comparing that instance to another instance of a tile that has the coordinates of 5.1 as well. And then we're comparing those two different instances, and they aren't actually the same instance. So it's saying that the tile list does not contain that tile, but really we want it to say that it does contain that tile. So this is a simple fix. We can actually just override how we're comparing tiles within the tile class itself. So if we go back to our tile class here, similar to how we overrode toString, we're going to override two more methods. And the first one's going to be the hash code, and the second one is going to be the operator. So I'll just put these here and explain it a little bit. The hash code is just going to return an object which has the column and the row, and then this is basically what's going to be used within our operator here. And the operator is really just going to be checking if these things are equal. So when this is passed something to look at, so basically we have two instances of a tile, and we're trying to see if these are equal to each other. This is kind of what is used under the hood when you're using .contains. And we're just going to be checking if the two columns are the same and if the two rows are the same. And if they are, then we're going to consider this the same tile. So if we rerun this now and hit play, and we hit that 5.4 again, you'll see now the 5.1 does highlight. And if we hit the 5.4 again, you'll see now 5.2 highlights. If we keep going up, you'll see it goes all the way to 5.5. And if we click it again, you'll see just nothing is happening. We're getting that block hit where we're returning null, and then we're just returning out of our make move function. So this is a good setup right now. We're able to kind of play the logic of the game as the user. Next, we're going to set it up so that the AI or the computer is actually going to play their move. So now within our make move, after the player adds their tile, we want to make the AI move. And we're going to extract this out to a new function called make AI move. We will need to notify the listeners after we call that. So make AI move is going to return the new tile that they move to. So we will have it return a tile. Potentially it could return null. And this is going to be the case if the board is completely filled up and the player makes the last move. Then the AI will have no moves left to make, so it's just going to return null. So the first thing we're going to do within this is create a new list of available tiles to use. In this version of the game, the AI is just going to randomly choose an available tile and use that tile. There's a couple ways you can do this randomization. I'm going to do it where we're going to find every single tile that is available and then just have the AI choose one randomly. Another way you could do it, which is maybe a little bit simpler, is to go and only choose the columns that are available and then just choose one of the columns randomly. Now the problem with the random feature is it's really not going to be good at playing the game, but once you see the whole structure of all of this, you'll be able to go in and update this make AI move to be smarter and, for instance, have it look for when there's 3 tiles of the opponents in a row and then block them and set up different logic within that that would be specific to your game. I'm not going to cover that in this video, but if that's something that you would be interested in seeing, comment down below and I'll consider making a follow-up video explaining just that. But back to this, we're going to create a double for loop. So we're going to loop over every row and then every column. And this is just going to basically give us access to every single tile here. And then we're going to define the tile with each of those row and column options. And then we're just going to check if it's blank. And if it is blank, we're going to add it to that new list that we have up there. So now this available list of tiles is going to be all the tiles that are blank. So if the board state was something like this, it would have all the tiles except for these 3. This is probably not the most optimized way of doing this. As I said, there's several ways you can do this, but for now, we're just going to leave it at that. The next thing we're going to do is just check if this available is empty. And if it is empty, then we're going to return null because there's no available moves for this AI to make. But if there is a move for that AI to make, then we can go ahead and add that to the AI taken. So we have this list of available ones, but we need to actually get a random one. So this is going to be a random tile, which will be the AI tile. And this is going to equal one of the available tiles. We're just going to choose one at random. So we're going to go for a random item in this list, which we can use random.nextInt and then pass it the length of this available list. We will need to import math and end that with a semicolon. If we were to keep this like this, because available is all of the available tiles, it could choose any of these. So we need to call our evaluate move on this so that this tile is actually going to be evaluated and moved down to the bottom. Now this is going to complain to us because evaluate move could potentially return a null value, but we know that it's not going to return a null value with any of these random available options. And this is because we already checked that this is available. When the player is playing, they might click on a column that's fully filled and then that would return null. But in this case, we know that this tile is available. We just don't know if it's on the bottom of the column or not. So evaluate move in this case is just going to move the tile down to the lowest available space. So with this tile, we can either return it and add it to the AI taken in the make move, or we can just add it to the AI taken here. And I'm just going to add it here. So AI taken is going to now have that AI tile. And we're going to also return this AI tile because we will be using this later to check if the AI actually won. And maybe, I don't know, maybe since we are returning this anyway, we could go up to make move here and just call this the AI tile. And maybe that is just as good. In fact, this is probably better because we can also set a message here that there are no moves left. So we could call this, yeah, so we will do that. We'll say alert that there are no moves left, because if the AI file returns null, that means that there are no moves left on the board. So we would want to alert the user that and basically just have them reset the game. Now, if we save this and we'll just rerun the whole thing and hit play, we should click ours and you can see the AI is immediately playing, and every time we click one, the AI will immediately go right after us. So this is good. Now the AI is starting to play against us. The next thing we're going to do is determine who actually won. Now we're going to talk about how to determine if the game has actually been won by either the player or the AI. So obviously, you know, in playing Connect 4, you just need to get 4 in a row, either vertically, horizontally, or diagonally. And if you start to think about it, there's actually 16 potential win states that could occur from one tile being played. So the way we're going to determine if the player won, we're going to check the tile that they just played and then look at the 16 potential win states around that tile. So let me show you this a little bit more visually. Imagine you play this tile here. These are the 8 horizontal and vertical potential win states. So this tile could be part of these 4, it could be part of these 4, it could be part of these 4. Basically, there's 4 options it could be a part of going vertically, and then 4 options it could be part of horizontally. We're going to begin by just setting up the logic for the vertical one, then we'll set up the logic for the horizontal one, and then we'll move on to the diagonal ones, which are actually, these are the 16 full potential ones. This image gets a little bit confusing to see, but it's the same concept. It's just that cross here, but also diagonal. So this X, this key that was played, could be part of any of these 16 win states. Now you can imagine that this tile here is actually our 1-1 tile, which would mean it's in the bottom corner. So basically what that would mean is none of these win states out here would be an option for that tile. So our math is going to have to account for that as well. It needs to know not to look to the left or to look basically at any of these tiles over here because it's off the game board. All right, let's get back into here. And actually we have a slight bug. When we hit reset, our AI tokens are still there. So if we go back into our cleared board, you can see, yeah, this is a typo here. This should be AI. And if we now hit clear, everything actually clears. Now we can create a new function, and this is just going to return true or false if the player just won. So we'll call this check win. So again, we're going to be using that play tile and checking if it's part of any of those 16 win configurations. And if it is, then we're going to know that the player won. So we want this function to work for both the player and the AI. And without passing a bunch of parameters, we can determine who this tile is. And really what we're going to be needing is the list up here that corresponds to that user. This is a way that we can actually get that list of the taken tiles. So this taken tiles is either going to be the player taken list or the AI list. It's just going to get the game owner and see if the game owner is the player, then we're going to use the player's taken list, and if not, we're going to use the AI taken list. Now we can use this, and this will be a generic check win function that we can use for any tile that's played. The logic for this will get a little big, so we're going to break this into 4 separate functions, and the check win is just going to call all 4 of those functions. The first one being the vertical check. So back in our illustration, we're going to be checking for these 4 potential win states here. So we can start by creating that vertical check, and it's going to return us a list of tiles if those tiles are the winning tiles. And the reason for this is we want to color the winning tiles a different color, because once someone wins, we want those tiles to turn green. We're going to create a new list, and that's going to be for those win tiles. So this will return a list of 4 tiles, or it will return null. And if it returns the list of 4 tiles, then we're going to set that to the win tiles. So let me actually show you how we're going to call this, and that will maybe make this make a little bit more sense. So within our check win, we're going to call our vertical check, and if our vertical check is not null, then that means it returned the 4 tiles that are the winning tiles, and then we're going to set our win tiles equal to the tiles that were returned from this check, and then we're going to return true out of our check win function. We can also return false down at the end here, because if this doesn't win, then we're going to assume that we did not win. So now we need to check if the tile that was played, so for instance, if I played this tile here, we need to check if this tile here is currently part of a winning line. So first we're going to define a temporary list that we can hold some tiles in, and then we're going to loop over the rows that this tile is in. So because of the way Connect 4 works, the tile that we're playing is always going to be at the top of the row. There's never going to be tiles above that tile. What we can do with this loop is start at that tile and just start looking at the rows below it until we get to the bottom of the board. We're going to start at the row, so currently the row is 1 for this tile, and we're going to go while the row is greater than 1, and then we're just going to keep going down. For each iteration of this, we're going to create a new tile, and it's going to always have the same column because we're only checking in this column, and then we'll give it the row that we have there. Then we need to check if this tile is in the taken tiles for this user, and if it is, then we're going to add that to our temporary win tiles, and if it's not, then we're going to break out of this. What this will do is basically add to this list all the tiles that are directly below the tile that you played, as long as it is your tile. So if we had this state now, it should add both of these. And just to demonstrate this, let's go ahead and print out the temp win tiles. And we will actually need to call our check win. So back up in our make move, after the player makes the move, we can call check win and give it that new tile. If we click on one of these, you can see our tile is returned. And if we click on the 4-2, we would expect 4-2 and 4-1 to be there, which is exactly right. And then same with 4-3 and 4-4. And that's exactly what we would expect. So now we need to decide when we should return this list, because if the list is only 2 or 3 long, it isn't actually a win. So we want to return null in that case, which will be the default. We need to check here if the temp win tiles length is greater than or equal to the win state, which in Connect 4 is going to be 4. This you don't necessarily need to hard code here. We could put this into our board settings and create a new function called the win condition, which will make this more flexible, and depending on the level you could change that. So let's just quickly add this into our board settings, and it will be an integer for the win condition. And for right now, we're just going to return 4 here, but that kind of abstracts this out so that you can make the win condition different for different board sizes. So if this length equals our win condition, then we're going to return the list, and that will be our temp win list here. Currently, when we return this from this vertical check, up here in our actual check win, we are getting our vertical check, in an actual win case, this would set win tiles equal to the vertical win tiles that we placed down there, and then we're going to return true. So with our check win here, this is going to return a bool that can be did player win, and then we can check if the player did win. We can actually set the win state for the game and make that confetti run. So for this, we're going to actually need another change notifier that we can then tell our play session screen that the player actually won. So this one is going to be a lot simpler, and we can actually define it within our board state. So it's going to be a change notifier within a change notifier. After the win tiles here, we can define, we'll actually define two, that the AI one and the player one, and they're just change notifiers. And then down here, when our actual win state happens, so the player did win, we can just call that player one change notifier and tell it to notify its listeners. Then we're going to also notify the board state listeners so that we can change the colors if needed. And after this wins here, we're going to just return, because we don't want the AI to actually go and make a move if the player just won. We do need to go into the play session screen here and update our change notifier. So instead of returning this, we're going to actually set it as a variable, which we're going to call the board state. This can be a final. And then we want to take this board state and call player one and add a listener to it. And the listener is already set up within this template, and that's the player one, which is that it's going to show the confetti and move you to the win screen. So we can go ahead and reuse that, and then we're going to have to now return this board state. Earlier I did say that we would do the same thing for the AI one, but in this case we're actually not. If the AI wins, we're just going to pop up a notice that says you lost and that you can reset the board. Now if you want to get more advanced and have an actual loss screen and everything like that, this is how you would do it. You would just kind of model it after this win state, and you would have like a lose state. But back here, we can actually just go ahead and remove the AI1 change notifier, because we aren't going to actually use that. But now that this is set up, if we rerun this and get a win state for our player, you can see the confetti happens. It says you won, and then you can click continue. Now the continue page here, you'll notice brings you to the level select, and we really want that to just bring you to the game again. So we can quickly update that. And this is going to be in the win game down here. And you'll see on this on press, the Go router is popping. And we want to just hard code that back to the play session of level 1. Go back here. If we hit play now, and we get to that win state, you can see we'll get that continue button, and now it's just a new game. And maybe we try, maybe instead of continue, we can say play again. All right, that is good. Now the last thing we need to do with this win state for the vertical is actually to change the colors. So this is relatively simple because we have our win tiles now in that list. We already have set that up. In our color tiles down here, we're going to create a new if statement that's going to check if the win tiles contain the tile that was just played. Then we're going to set that equal to, this will become an else if. Then we're going to set that color equal to green. All right, so now if we play this and we get that win state, you'll see they turn green and we get the confetti. Everything looks good. We can click play again. So this is good and it's working, but we can only win with a vertical 4 in a row. So I don't know that it's going to be super useful to explain the logic behind how to determine these win states, because now that you saw how it's done for the vertical, you could probably figure out how to do it for the other three being horizontal, diagonal down, and diagonal up. But I'm going to have the code on GitHub, and I'll show it here real quickly, but I'm not going to fully explain it because it's going to be a bit time consuming, and this video is already getting quite long. So what we're going to have in our check win here is very similar to how we have the vertical check. We're going to have the horizontal, the forward diagonal, and the diagonal backward. And this is going to be about it. All the logic is now here. Basically for our horizontal check, just like the vertical, we're going to take the horizontal, but we have to look left, and then we also have to look right. So we're going to take this and we're going to start looking left. We want to also make sure that we are not on the very end here, because if we are on the very end here, we're not going to look left. we're just going to look right, but we'll look left and then we'll look right. And if we have those 4 tiles, then we're good. One thing to notice about the horizontal one and also the diagonals is we are going to start this list with the actual play tile. And that's something you could do with the vertical check as well. But we're going to start it with the play tile. And then when we go left, we're always going to start 1 tile to the left of it. And when we go right, we're going to always start 1 tile to the right. But that's basically it for that. This concept of looking 2 directions is going to be used in the diagonals as well. And it's basically the same thing. You're just going to look to the left and you're going to look up 1, and then you're going to look to the right and look down 1. And then for the other diagonal, it's going to be opposite. You're going to look left and down, and then you're going to look right and up. But that's basically it. And it looks like a lot. I mean, it is a lot of code. This could probably be refactored and potentially made simpler. But with code like this, you want to be able to understand it and read it. So if you're able to read this and understand it, that is the point of the code. If you're not, definitely comment down below. Let me know where you're confused. And if you do want me to make a video explaining this in more depth, just let me know and I can definitely go through and do that. You'll see now if we replay the game, we can now win in basically all the way. So there's a horizontal win. To show the diagonal win is a bit more difficult with this AI because you typically always end up getting a horizontal or a vertical. So I'll just comment those out real quick just so I could show you. And you can see there is the vertical win, or there is the diagonal win. And it will work the other way as well. So all the 4 potential win states are all working. So currently the AI cannot win the game because we aren't actually checking its pieces for the win state. So we're going to update that right now. So very similar to how we check the win state for the player, we're going to check the win for the AI. And because we're passing in a tile where the owner is the AI, the way we wrote that function is going to check the AI's tiles instead of the player's tiles. Just like up here, we will check if the AI won. So if that's true, we're not going to notify the listeners here, but we are going to send a message that the player lost. Now the AI can technically win, but there you can see the AI did just win. So now another thing, since the win state didn't come up, you'll notice the reset actually didn't reset these. So we need to go up into our reset logic and also just clear out the win tiles here. So now if we reset it, those will be gone. So now both sides can win. You'll notice we have these to-dos here for these messages. So let's actually go ahead and create that message setup. We're going to do this with a new variable that is going to just be a string, which will be called the notice message. And then when any of these to-dos are here, we can just set the notice message to something. So this move is not possible, so we'll just set the message to move not possible, try again. Another thing that we want to make sure we do is actually clear out this message when we reset the board. So let me do that real quick. And there's 2 other messages we need to add. There's no moves to make. So the notice can just be no moves left, reset to play again. And lastly, this would be when the AI actually wins, we can set the notice to you lost, reset to try again. I guess we can just play. So the easiest one of these to see is when you try and play a spot that isn't available, but actually we aren't displaying the message anywhere. So we need to go back and add that in. Back in the play session, we can, instead of having this list down here, which is really no longer needed, that was kind of just used for development purposes, we can change this to be a text widget, and within it we can just put the notice, which will just be that notice message from the board state. I'm also going to take this and move it above the reset button. So let's put that here, and we can put a spacer here as well. All right, so you can see that message is showing because I clicked here, and if we reset that, the message goes away. If we try again, of course we won because the game is quite easy, but if we try this again and we click this, it's actually not working right now, and the reason for that is we're not notifying the listener. So we need to make sure we call notify listeners after each one of these is changed. So that one didn't have it, and neither does this one. So now you'll see that works. And just to demonstrate that this actually does work, you can see no moves left, or move not possible, try again. So one last thing we're going to do is actually delay the move for the AI and lock the board while the AI is playing. So you can notice if you click real quickly, you can keep clicking even after you won. So we want to lock the board to prevent that. We also want to have a slight delay between when you play and when the AI plays, so it looks like it's actually thinking. This is stuff that's going to make the game a lot better as you go, is adding these little details like this. The current state of the game is pretty much quick and very programmatic, so it's not going to be that much fun. This is one example of adding a detail that will make it a little bit more fun. So back in our board state, we're going to add a new variable here, and it will just be a bool value, and it's going to be called isLocked, and we're going to default that to false. When we clear the board, we want to also make sure that that gets set back to false in case that it was true. So when isLocked is true, that means the board should be locked and you shouldn't be able to play. So in the make move here, we can assert that isLocked is not true. So if isLocked is not true, then that means you should be able to play. This gets a little bit confusing because it's like double negatives, but this just means that the board is not locked, so you should be able to play. This assert here will basically fail if isLocked is true, and nothing below it will run until isLocked becomes true. So now we need to actually set isLocked to true at specific points in the game. So after you take the player tile, so player tile is added, we're going to lock the board right here. So then we can check if the player won, and if they did, great, notify listeners, go to the end screen. If not, this is where we want to actually add the delay. This is where we want the delay in the AI's turn. So this we can do with a future, and we're going to await this. So we need to make this an asynchronous function now. And that means this is going to be returning a future void, but we're going to await a future void, and it's just going to be a simple delay, and it's just going to have a duration of any amount of time that you want. I'm going to use 500 milliseconds. After that delay, have the AI make its move, and then after it makes its move, we're going to unlock the board. So we'll just set it equal to false. So if we rerun this, it should actually work. So if you hit play now and you click a button, you'll see there's a slight delay, then the AI goes, and you're no longer going to be able to click after you won or during the AI's turn. That's as far as we're going to go in building this game in this video. There are a lot of things we could do for next steps. A few examples are adding more sound effects, adding more animations, obviously making the AI's moves smarter. That's probably the most important one. Adding things to Game Center, adding in-app purchases, adding ads, also going back and adding different levels, making the game more interesting, making it more fun. The purpose of this video though was just to show you how to use this game template, how to build within the structure of this game template. Again, big thanks and shout out to Philip, who actually built this and built the tic-tac-toe example, which this is actually based off of. I would definitely suggest going and checking out both of those code bases. When I was getting started with all of this, there was really nothing that kind of walked me through completely step-by-step how to actually use this. And so that is why I made this video, and I hope you guys find it useful. Comment down below if you want to see anything else or if anything isn't clear. I'm planning to make a Flutter game over the next couple of months, so I will be doing a lot more Flutter development. So if that's something that you're interested in, you can subscribe and follow along. I'll probably make a couple videos throughout while I'm doing this. Overall though, I just hope you found this video useful, and I hope it helps you build your game. Join the Discord server and we can chat over there. All right, ciao for now.